So here's a couple of packages. Now, I'm not recommending that you use these packages. I'm just showing you differences between what actually complies. I apologize for the switch between metric and English units. There's a reason for it, but I'm sorry. So this is an R50 roof, an R18 wall, right? This is a triple pane window, a good triple pane window at 0.18, so that's greater than an R5 overall. That's your overall window U value. We've got R10 under the slab and down the vertical, down, but I think 3 feet vertically. The ERV is only at 75% efficient. That's the minimum efficiency you can have for an ERV for passive house, okay? It has to be 75% efficient or better. And we'll talk a little bit more about that. Mini splits, good VRF system. So it passes all the thresholds here. The threshold, you can see the thresholds are right here in metric, okay? So those are the metric thresholds. And so you can see we're pretty high on cooling, right? We're almost at our threshold, but we're really, we're only half the heating threshold. But we're really close as well to our primary energy demand. When you go through the design process, especially at the beginning, you want to hold these numbers down pretty far so that as things come up during construction, as you need to add windows into place because your client wants more windows, as you change your equipment, or you need a different refrigerator because the one you wanted is no longer available, and that now we have to enter more energy for that. Different things happen. Oh, we couldn't get insulation in this spot because of something. Or now all of a sudden we need fire-rated windows, which happened on my project, in these 2 floors, which are way worse efficiency-wise, but code says we need fire-rated windows. So the numbers start to creep up as you go. So when you first do your design process, you want to give yourself a contingency budget, right? Like in construction, you want a contingency budget. So this next package also complies, but we're really close to our primary energy demand on this one. And what we did was we put in a worse window at a 0.25, so this is assuming a double pane window, and R30 in about half of the facade and R18 because the facade changed in depth. And then the other values were the same. So this package here, we're already at 120. I would never recommend you go into construction at this level. You got to give yourself some room, okay? These windows are a little controversial. Again, we tried to push, if we could meet our energy budgets, could we use a double pane window? But when we looked at the temperature of the surfaces and the condensation potential, we had to chuck them. So, those condensation, comfort, durability, those are all the soft requirements I'm talking about. And there's a few there. You need to have operable windows in all living spaces. They don't have to be egress, but they have to be able to open windows. They want the occupants to be able to get fresh air if they want it. Again, they want your overheating frequency to be less than 10%. And that's 25 degrees is about 77 degrees Fahrenheit. And then they want you to be able to adjust the ventilation volume flow rates and indoor temperatures. So this might not be practical for a high-rise building. It might not be practical for commercial space or residential space. Do you want somebody in the commercial space touching your ventilation system in an office building? I think no, I don't think. It's bad enough with temperature. We fight in our office over the temperature all day long. You don't want people touching the ventilation system. Like, come on. Holy smokes, would you be in trouble? So in a multifamily building, it causes trouble as far as controls, complexity of the system. Can you actually do it? They're listed as, so those energy budgets I gave you are considered the hard criteria for passive house. These are considered soft criteria. The other one is the temperature of the indoor surfaces shouldn't be any more than about 8 degrees different from your interior air temperature. So they don't want to see your surface of your glass under 59 degrees because they're assuming a 68 degree interior temperature, okay? So these are all supposedly soft criteria. I don't know how soft they are. They fight with us on this stuff all the time. So I would pay attention to these really, really heavily. I think they don't come into play much in residential buildings because you really can't get to passive house standard with lower levels. So you're pretty much assured that you're going to have great surface temperatures and no condensation problems because you have to put in higher levels of efficiency. When you start to get into these and you can squeeze your efficiency levels down, that's when you got to really start looking at these soft requirements. They're more strict if it's in a habitable space like an apartment or an office building where someone's going to be sitting there all day. In a lobby, in a fitness room, and something like that, they're going to be less strict on their values. Okay. For instance, in our lobbies, you can put in a curtain wall system, and it doesn't have to be a high, triple pane, super insulated curtain wall system. You can get away, if you can meet your budgets, you can get away with a less thermally insulated window system in those spaces. So I think I just covered this. This is what the 3 criteria are for the comfort criteria. They don't want you to deviate more than about 7.5 degrees from the average operative temperature. I think it's a little higher than that, actually, but that's about average. So, and then the surface temperature should not be, so there's this sort of a conflicting thing here, but the surface temperature should not be lower than 55 degrees or greater than 132 degrees. And just so you know, the condensation point that they use in their analysis is they assume 68 degrees interior temperature at 50% relative humidity, which, good God, your spaces should not be at 50% relative humidity ever, but in the winter. But the surface temperature shouldn't be anywhere near 49 degrees because that's the condensation point. Okay, just for your reference, if you're evaluating something, you want to make sure it's above that temperature for sure. And then the surface temperature of the floor must be between 66 and 81 degrees. They don't, because your feet are so sensitive to temperature, so they don't want those to vary too much. So typical heating and cooling requirements for a passive house. Heating and cooling is needed in these buildings. You can't get, you're probably never going to get away from that. That's a requirement. In a lot of our residential buildings, cooling is not put in, depending on where they're located. But in these buildings, you're definitely going to have cooling. Individual control is desired in some circumstances, maybe not in an office space so much, but in an apartment building, in a dorm, something like that. You're going to need to make sure that they have control of their thermostat. The equipment itself needs to be very energy efficient. You don't necessarily need photovoltaics or solar thermal on your building. But you will need very high efficiency equipment. So we're looking at condensing boilers, we're looking at mini split systems, we're looking at very efficient heat pump systems. I have had residential projects that could get away with an inefficient heating system versus a really efficient hot water, or vice versa. But in these buildings, you're going to need to do both. And then yeah, the issue here is that you have limited ceiling heights and floor plans. Where do you put your equipment? Do you run ductwork? How are you going to deal with this, with these issues? So just some basic options for high-rise that I've seen go into passive houses, and you might think that this is kind of crazy, but I've seen projects with a central boiler for the heat, and the radiators in each apartment room are like this big. It's so funny. You're like, that can't be good, but it works. And then combined with a window AC or a sleeve AC. Now the AC itself is not very efficient. The cooling load in that apartment is very low. So the big problem with that AC unit is not the efficiency necessarily, it's the air leakage. So when we do the blower door test, how do we solve that problem? So you have to make sure you have a unit that has a very tight air seal cover that will go on the interior, right? So that as a building, you can adjust, you can go and fix those and make sure they're tight. And then if you're using a window sleeve or a wall sleeve, how do you air seal around that? And then you have to account for the thermal bridge of that piece of equipment through the wall. So it can be done. It can be done. It just can be compensated for in other ways. We've also seen individual air handlers in each apartment or each space, and which do, a split system, which do both the heating and the cooling, and then mini splits. The easiest thing to do for high-rise is, if you're using heat pump equipment, is to find a condenser room. You don't want to hang all these things. You can see them all on the outside of this building up here. This is a low-rise multi, but you're not going to do this up your high-rise, probably. I think you've seen pictures of these from Japan, where they go all the way up the high-rise buildings. I know that's not very favorable to a lot of architects. And it's also a lot of penetrations. honestly, through your facade. So you want to find a condenser room. You can probably use a single large condensing unit to run many multiple concealed cassettes or, whatever you want to use for your heating system. Central works well because the floor plans are so small. Getting the mechanical equipment into the apartments are really difficult. Okay. So the pros of the first option are that it's a pretty low first cost. Central boiler, people can do that all day. Window ACs are very cheap. You can very easily size the heating system to match. One of the issues with passive house construction is they're so efficient that the smallest heating systems, individual heating systems, are much too large for the heating and cooling loads. They're just way oversized. We can't get anything small enough if you're looking for individual systems for passive house projects. So central tends to make more sense because then you use one, 6-ton compressor and you can heat the whole floor, however many apartments, 10 apartments. The problem is that the AC is typically inefficient and the leakage is hard to control, and then you've got an extra thermal bridge. The HVAC, individual air handlers, it's easy to meter the occupants, right? So if you want to sub-meter your occupants, you can do that very easily. The cons are, like I just said, the systems are not small enough, so they'll cycle readily. If humidity is a problem in the area, you're not going to get the condensation or the humidity control that you want out of your air conditioning system because it'll be too big. Floor plan alterations will need to accommodate the ductwork. And then electric is the typical system because you want to eliminate any venting, any combustion venting, if you were using gas systems, which is another penetration through your facade. So this one I don't see so much. The first one I see more of, and then this is generally the go-to system. Mini splits. So the pros are you can also, even on a common condenser, many of the manufacturers offer software that help you sub-meter all of the occupants. So if that's what you need to do, it's available on a common mini-split system. It is the most efficient option for a combined system. You can run it at part load very easily. They go down to part load, a very small part of their capacity. The first cost is high, and then you might have some limitations with refrigerant lines, where they can go, where they can cross, and how much refrigerant is in the lines due to the length of it. So that's just a code issue. We had to deal with this code issue. The code's changing, making it a little bit easier to run long lengths, but still it's something that your mechanical engineer is going to have to look at for you if you're looking to do this. Okay, that's just a heads up on that one.